Hello everyone, welcome back to my YouTube channel. In this video, we shall discuss on a question related to determination of Kp. A sealed 5-liter reaction vessel is initially filled with 0.4 mole of hydrogen gas and 0.4 mole of iodine gas at 500 Kelvin. The system undergoes a controlled reaction to form hydrogen iodide. At equilibrium, 0.6 mole of hydrogen iodide is present. Using the stoichiometric relationship, determine the equilibrium constant Kp for the reaction at 500 Kelvin. Alright, so the first step to answer this question is to write a balance equation for the reaction. So the reaction is between the hydrogen gas and also the iodine gas. So hydrogen gas plus the iodine gas, it will produce the hydrogen iodide. So we need to balance out because you have 2 hydrogen and 2 iodine here. So we just have to put 2 around here. So next up, we are going to do the ice diagram. So basically, in the question it says that for 0.4 mole of hydrogen gas, so here will be 0.4, and then another 0.4 mole of iodine gas, so here is 0.4 mole, and initially there's no hydrogen iodide. And then a change, because we have only 1 mole, so negative x plus 2x. Therefore, you will get 0.4 minus x, 0.4 minus x, and this should be 2x. Alright, now let's see what other information that is given in the question. So, in the question it states that the system undergo a controlled reaction to form hydrogen iodide, and at equilibrium, 0.6 mole of hydrogen iodide is present. So, at equilibrium, 0.6 mole of Hi, hydrogen iodide. Therefore, we can say that 2x is equivalent to 0.6. Therefore, x is 0.6 divided by 2. So, your x is equivalent to 0.3. So, what we are going to do is we are going to replace all these x's to 0.3. So, basically, what we are going to do now is we are going to find what is the actual value at the equilibrium. Alright, so now we are going to substitute all the x's with 0.3. Hence, you will get here is 0.1, 0.1, and 0.6. Right, this is the value at equilibrium. So basically, this is the number of mole. So what we can do now is we can calculate the total number of mole at equilibrium. So it should be 0.1 plus 0.1 plus 0.6, and you will get 0.8 mole of gas at equilibrium. Alright, so from the calculation just now, we already know that the total number of mole of gas at equilibrium is equivalent to 0.8 mole. Alright, now we are going to use the ideal gas law to find what is the total pressure. So the ideal gas law, PV equivalent to nRT, and we want to find what is pressure. Therefore, we are going to use nRT divided by V. So the N is 0.8, R is the normal R gas constant, which is 0.0821. So this shall be in liter atmosphere over mole Kelvin. So this one definitely mole. And T in the question it states that it is at 500 Kelvin, right? Divided by the volume, which is 5 liter. So the first thing that we should do is we need to find what is it that we can slash out. So liter, and then we have Kelvin over here, and also the number of mole. So we will end up with ATM as the unit. So all you need to do is you just have to plug in the values in your calculator. You should get the total pressure should be equivalent to 6.5 0.5680 atm. So this is the total pressure. Alright, so from the previous calculation, we already know that the total number of mole is 0.8 and the total pressure is 6.5680. So now what we are going to do is we need to know what is the partial pressure. So the partial pressure for hydrogen and the partial pressure for iodine gas should be the same because the number of mole for both of them are the same. So the partial pressure is the mole fraction, which is the number of mole at equilibrium, divided by the total number of mole, 0.8, times the total pressure. So the total pressure is 6.5680. Therefore, you will get the partial pressure for hydrogen and also iodine is supposed to be 0.8210 atm. Right, so moving on to the partial pressure for hydrogen iodide. So it should be equivalent to 0.6 divided by 0.8 times the total pressure. So you will get the partial pressure for HI equivalent to 4.9260 atm. Alright, so moving on, looking at this equation, we can actually calculate the Kp. So the Kp is whatever in the product divided by whatever in the reactant. So your product is Hi, so partial pressure for Hi, because you have 2 here, so to the power of 2 divided by the partial pressure of H2 times the partial pressure of I2. So we are going to use the value that we have calculated just now. So 4.9260 square. So this one should be the same as well, 0.8210 square. So you will get your Kp should be equivalent to 35.9999. So this is the final answer for this question. Thank you very much for watching this video from the beginning till the end. So I'll see you again in the next video. Goodbye.